Hey, let's get started. Welcome back to week 2. Feels good having a week under our belt, right? Sort of got the idea of how things are going to work here, right, for this and your other classes. I got up here and I'll probably start most classes like this. Here's the list of homework assignments, right, and the due dates. So there's that easy orientation assignment, right? But keep in mind that is actually due on Wednesday. That's due on Wednesday, right? And almost everyone is enrolled in my math lab. There's a handful of people who aren't, so you will have to, prior to that assignment being due, right, because that is a grade in your homework. Remember, you have the grace period, right? So there's nothing preventing you from enrolling in the course, right, and working, and then you can purchase the access later, right, when you have the money available. And then we have another homework due on a week from Wednesday, so you get a little bit of a break because Monday's a holiday, right? Okay, so so that next homework you get a little bit of extra time for. That one's not due until next week. And there are lots of other things here that I put up over the weekend, okay, that we're going to get to soon, right? So so these things are coming up. Don't forget that algebra review, right, which is not due until the first test, and you can be working on that a little bit at a time. So about a third of you have started your these two assignments, okay, so I'd like more of you to get started, and because especially, right, you had this one. But this one's easy, but don't wait till the last minute, especially because, although it's easy. It's due midnight Wednesday, right? But and usually homeworks are due at midnight, except in some circumstances. The thing you have to be careful about is in this week, my math lab can be really slow, all right? And so I noticed it was slow this morning because a lot of colleges are starting today, okay? And a lot of people are registering in my math lab, and a lot of people are starting to use my math lab. So it may slow down here in the first week or two, all right? And since most people make their homeworks due at midnight, it's liable to be slow around midnight, okay? So be careful about that. So don't wait there till the last second to finish those easy homework assignments. As soon as Taylor gets here, we will. She didn't email me, so I think she'll be here. We will. I'll go ahead and give you your name tags again, right? Taylor will pass out the name tags, and we are also going to take the roll today, okay? When Taylor gets here, let me put this over here so I will remember this, okay? So today will be our first day of signing the. Today will be our first day of signing the roll sheet, right, for the attendance policy, okay? So I think some of you have already noticed, right? Again, the notes and the video lecture seem to be working so far. So those are posted on the Blackboard page, not in Course Compass, but not in my math lab, but in the Blackboard page under that section that says class notes and videos, right? So go there if you want to find the video of the lecture or just the notes that we're taking in class, right, are posted there. Or the notes that I'm lecturing from are posted there. Okay. That's kind of our warm-up. Do y'all have any questions right now about anything so far? Okay. Well, we'll see, okay? This class sort of makes or break my day. So if we have a great class, then I'll have a great day, okay? So y'all can help me make my day great, right, by participating really well here in class, right, okay? And help, and let's work together to get this material done. Other questions? Yes. Well, we will have. We don't really have other outside assignments, okay? These are your homeworks, all right? But we will have class activities, right? You know, we do a lot of activities here in class, some of which will go into your homework grade, okay? And so most of those I don't collect. They're just practice things, right, for us to work on to prepare for the homework. But there are a few of them that are a little bit more extended, and I will collect those to give a grade on. Okay, but that will just go into your homework score. So the answer is kind of. All right, right. Okay. Someone else was mumbling there. Was there another question? What? Oh, just, everybody participating, right, okay, and working on the stuff that we're doing in class, right, and participating in the lecture, right, and staying engaged in the lecture, okay. That's what makes a great class day for me, okay. All right, and for you too, all right. Participating in class and staying engaged in the lecture is really going to contribute to your being successful in the class, okay. All right. Okay, let's go back to the notes. Speaking of staying engaged, right? Let's go back to the notes then. And just as a little bit of warm-up, we want to remind ourselves here. So these were in the notes from last time. You may have already worked on these, okay? But we didn't talk about them explicitly in class. These first two examples, A and B, we skipped to C and D last time. Remember last time we were just briefly reviewing the order of operations, right? When you're simplifying an expression, in which order you carry out the operations, correct? Remember, when you simplify an expression, in our definition of that term, when you simplify an expression, that means you're going to carry out the arithmetic operations in the expression, right, as much as you can by hand, right, until you reach a point where you just can't carry any more of the operations out by hand, all right? Okay, so here are just two arithmetic problems. They don't involve any algebra. There are no variables in these two expressions, A and B, right? Okay, but let's see if we can simplify them. So let's see if we can carry out the arithmetic in those expressions, right? And remember, that's really easy to do. If the arithmetic is straightforward, it's easy to do, okay? And so I think here, well, I'm not sure, okay? I think for the most part here, the arithmetic is going to be pretty easy. But simplifying expressions is fairly easy in most cases, or at least straightforward in most cases, if one follows the order of operations, right? And here are the order of operations, remember, that we're going to use here in this class, right? Okay, and that's very standard order of operations for any algebra class, right? Okay, so remember parentheses and then multiplication and division, but you have to go left to right because multiplication and division have the same precedence in the order of operation, and then addition and subtraction, right? Also from left to right because addition and subtraction also have the same priority in the order of operations. All right, so as a quick warm-up there, see if you can simplify A, all right? And if you want to, you can go ahead and do B because it's not much more difficult, okay? So let's just take a couple of minutes. If you did it last time, that's great. Just remind yourself what you did last time, okay? And you can use a calculator. It's not forbidden to use a calculator, all right? But most of these computations, I think you can do by hand, all right? A calculator is not really essential in these problems. And then we'll just take a look at our work here and just make sure that everybody's got the right answer here on this simple sort of problem, right? Okay, so we're minus Taylor, so I'm going to go around. If you have any questions there, just let me know. I do not know what the right answers are because I did not do these ahead of time, okay? I did not do my homework there, all right? So, yeah, follow PEMDAS, right, okay? Remember, that's the acronym for the order of operations, right? PEMDAS, okay? And the little memory device for that is, please excuse my dear Aunt Sally, although there are other versions of that, okay, is a way of remembering the order of operations, right, okay? Now, you won't often come up with an expression like this to actually have to simplify by hand. That one's kind of artificial, but it's good practice anyway, okay? So that one's just practice. So everybody write it down because I'm going to call on someone to share their answer, all right, with the class. So if you have questions, tell me there. But you can also talk with everyone's got Hershey bars today. Was there some sort of, was there?
I bought mine.
Okay, I thought maybe they were giving away and I missed out on that. Sorry. Okay, all right. Yeah, so remember you can talk to your shoulder partner, right? Okay, the person next to you on either side. And you can always talk to me and Taylor if Taylor were available. So Taylor must be stuck in traffic today. So we don't want to take forever, just a couple of seconds there to get that written down. So let's see. Yes, it's that goes first, right? Then this. And now what would you do next there? Oh, I'm sorry, you did it right. Okay, so there's the 3, and now here's where it gets a little bit tricky, right? Okay, because which of these things is going to go first, right? Oh, but you did it right. Okay, so I think that's correct, right? And so then we would have this and that. Well, I can't see a mistake, but I saw other people get different answers, so we'll have to see which we agree. Did you get something? So you got, because what did you do right here? Oh, yeah, so y'all need to talk about right there, y'all did something different. Okay, right? Okay. So I've already seen, well, now this is my third answer there. Okay, right? So I've seen 3 different answers. That's good, all right? That gives us a little bit to talk about here, okay? So is that right? Is it Geo? Is that right? Okay.
Yes,
Yeah, all right. See if she comes up with the same thing. You got 2. That's my 5th answer or my 4th answer because I haven't seen anybody with that answer yet. Did you get the same thing?
I haven't finished.
You haven't finished yet?
Because you say we go from left to right. Like, so even if division is in front, even though it's PEMDAS, we do division first rather than the multiple.
That's right, yeah. Okay. And that's what always throws people in the order of operations. That's always a trick question in order of operations. Yeah, okay. Well, unless the division is, remember, outside of grouping symbols, right? Okay. Because in grouping symbols, that takes precedence, right? Yeah, okay. What'd y'all get?
I got negative 14.
Okay, so that other people have gotten that, so I think there's a good chance that is right. Okay, I've seen this answer too, though, so that's something different. Did you come something, Sky? Oh, I see. So how did y'all differ there? Okay, because it looks like he came up with something. Is it Salma? Salma, what did you done yet there? All right, see if you can finish that off, right? Okay. Furman, what happened there? Still going?
Yeah, trying to.
Okay, all right. Still go there then. All right. Now, once you finish A, you can. A, you can go ahead and try B as well. That one's a little bit, maybe not even so hard.
So
Yeah.
only if it's parentheses, I would include the next.
That's right. Yeah. Okay.
I didn't do. So I'm okay. So it's still left to right, even if it
Okay, so
besides parentheses and exponents.
yeah, besides parentheses, those go first, right? This doesn't have any exponents, so but you would work inside here first, right? Okay, and then inside this big group, right? Okay.
Oh, you know what? The reason why, I didn't write this down right. I didn't write this correctly. So this is all one big.
Yeah, that's all
Yeah,
one
okay.
big thing,
That's
right?
where I went. Okay.
So like,
I know.
what do you do first? You still go in order of PEMDAS.
Fine,
But division and multiplication is interchangeable by which one is first.
Okay, so a lot of people have gotten through the first one. What about the second one? What does that come out like? Good start there.
We got stuck on this one because we both got different answers.
Yep. Okay. So we're gonna see. All right. So we'll have to settle that debate, right, of which one is correct there, right? So let's try the next one. So now, what would you do here? What's square root of 25? No, it's just 5, right?
Oh yeah, you're right.
Yeah. Okay. And then what do you have in the bottom there?
-3 -1.
Yeah. What's that? Yeah. There you go. Now. Okay. Mhm. Yeah, I think that second one's a little bit easier. What'd you come up with?
Break it down to at least a lower number. Well, we could do 7 over -2.
Yeah, so I'm going to give you a hint. That should be a whole number. Okay, I'll give you a hint on B. When at the end, you should have a whole number, not a fraction. So if you don't get a whole number on B, rethink what you did there. Okay. All right, Gio. What are you going to do first here?
Well, I'm gonna. Can these take each other out? Or no? We'll do
Can which ones?
the other two minuses.
Yeah, unfortunately not. We'll talk about why that's the case, though.
Okay.
Yeah, all right. So, so try doing the top. Try simplifying the top, and then simplifying the bottom,
Okay.
and then take care of the division. Okay. Yeah. So, but the threes will not cancel. I'll say why in a second here. Why that's the case. All right. So you're going to end up with not a whole number there. So something is a little bit off. You're almost correct, though. All right. Yeah, I'll see what, I forgot your name, but, yeah, look look at what he comes up with. Because y'all are going to vary a little bit there, right? Okay. Yeah, so we're getting some interesting.
I got that.
Yeah, so it's going to come out to be a whole number, though. So you're off a little bit. This is almost right, okay? Did you get something different? Oh, you got the same thing? Yeah, y'all are off a little bit somewhere. All right, so what would you do first there?
This.
Okay, so that gives you what? Yeah, that's right. Now what's 16 plus 9?
25.
Yeah, and then what's square root of 25?
5.
Yeah, so that's pretty easy, right? Skylar, did you? All right, so you got minus 14 here. Yeah, all right. All right, let's see what this one comes out to be. All right. Yeah, right. Okay. So you got a 5. What's the bottom there then? All right, Furman, you're going to end up with you're close. Yeah, you're going to end up with a fraction, but it should be a whole number. So what is going on there? Okay, should end up with a whole number. All right. Well, you are doing good. Okay, the tricks that I put in, some of them have tricked you. Okay, but that was kind of the point. All right. Okay, so we're going to talk about these, and we'll get it all straightened out for everyone. I'm going to call someone here just to share what they put on A, all right? But I'm going to ask you to come up, okay? So now I think I've messed up the cards from last week. So if I called you last week, just bear with me there until we get through everyone again, okay? So Ben, I'm going to have you come first, all right? So would you just come up front, all right? And show us what you did for A, and then we're going to see if we agree or disagree with that. Okay? No, just you can just show us exactly what you did, right? Okay. So there's a pin there, I think, if we need to write over that. Oh, Ben. So Ben scratched out something. So whoops, I've got to switch to the dot cam. Let's see if that. Oh, perfect. All right. Oh, so Ben, all right. So what did you do first that you decided to, let's listen to Ben. So what did you do first that you decided to change?
So I multiplied 5 times 3, which is
15, right? and then you divided 60 by 15 to get 4. I'm talking about in the scratch out, right? Okay, to get 4, right? Okay, and then you had 8 plus 4 is 12, and then 30 minus 12 is 18. So first time through you got 18, but you rethought that, so you changed that. Why did you change that? What did you do differently the second time?
So following PEMDAS, but it's left to right.
Left to right, okay. Division goes first, right. See, that's really tricky, right? Okay, and there's actually some disagreement about this right there. So in some situations, some people follow different order of operations, and they would get a different answer here, but we're going to follow the PEMDAS one just so we can all be on the same page. So according to PEMDAS, Ben, what really should you have done first there? When you had the 8 plus, in the parentheses, you had 8 plus 60 divided by 5 times 3.
Should have divided 60 by 5.
Yeah, I should have divided 60 by 5 first, right? And that would have given you what? 12, right? Okay. And then you would have gotten 12 times 3 is 36. 8 plus 36 is 44. And then 30 minus 44 is minus 14, right? Okay. All right. So why'd you decide to change your mind? Oh, okay, that's right. Your friend told you you were wrong. Okay, all right. So good advice from your friend this time. Okay, all right, perfect. That's great. All right, so y'all see. So some of y'all had some of you did have 18, right? Okay, which is really close. And some people would say that's correct, but in our class we would say no. The right answer is the right answer there is minus 14. Okay. Yeah. Well, yeah, I said there are different versions of the order of operations. Okay. So, and some of them are more elaborate than others. All right. But for our class and for most algebra classes, you'll follow PEMDAS. Okay. But in other situations, particularly in computer science situations, that order of operations might be different, all right, okay? So if you're a computer science major, I think some of you are, you might ultimately in your programming classes see a different order of operations in which expressions are going to be simplified, okay? And then don't say, oh, Dr. Waller told me this is wrong, and, okay, all right, they're just following a different order, all right, okay. All right, oh, we have the other one, right, okay? So the fraction, that one has a lot of interesting parts to it, okay? Is Arthur here? Arthur. Who's Arthur? You, Arthur? All right, Arthur. Okay, so show us. Okay, what you did there, all right? And I'm going to, as you're talking, I'm going to elaborate a little bit and say some things about this particular expression. Okay.
So I started with the exponents at negative 3 squared, so that was negative 9.
Negative 9. Why not positive 9, Arthur?
My calculator told me otherwise.
Okay, your calculator told you otherwise, all right. Your calculator is correct. Some people put positive 9 there, okay, for the minus 3 squared, but minus 9 is correct. Why? Because what about that minus sign? We talked about this. Yeah. It has to be in parentheses, right, if you're going to square the minus sign. So remember, in the order of operations, this comes directly from order of operations. In the order of operations, exponent comes first, not before subtraction, right? So you would square the 3 and then apply the minus sign. So that's why you get minus 9. If you want to square the minus sign also, you need parentheses around the minus 3. Oh, let me tell you one other thing, though, about this particular expression, okay, that sometimes is important, and I didn't mention this in the order of operations. When you're simplifying a fraction like this one, you can always assume that you have parentheses around the top and parentheses around the bottom. So simplify the top completely first and simplify the bottom, the denominator, completely next, and then do the fraction at the end, okay? Do not do the fraction first, okay? This is division, right, okay? But it's understood in a fraction that we have parentheses around the top and parentheses around the bottom. Okay. All right, Arthur. What did you do next then?
I just simplified 16 plus 9.
Yeah, 16 plus 9 is
25.
25. Yeah.
I just added the denominator after that, and I brought that down, and then I just square rooted 25, and I got 5.
You got 5. Perfect. Yeah. Okay. So really the order we should have gone in this is inside the square root first. So you would have gotten square root of 25. And then I would have squared there the 3 to get the minus 9. And then square root of 25 is actually also like an exponent. So remember we learned square root of 25 is 25 to the 1/2 power last week. So extract the square root of 25. You get 5. So that's technically the correct order, but you did everything right, okay? So this is fine. Now what?
Then I just simplified negative 9 plus 5.
It's minus 4, right, okay? And then you did the division at the end, right, okay, and got positive 1. There's the answer, positive 1. Yeah, that's the correct simplification there. How many of y'all got minus 7/2, minus 14 over 4? Yeah, okay, right, all right, yeah. And that's just the mistake you get if you forget about squaring the minus 3, right, okay? And that's a very common mistake. Some of you are going to continue making that mistake because it's just an easy mistake to make, in this class and in future classes, okay? But I hope you'll try to get past that mistake as soon as possible because it costs points and it's just an easy, it's points you don't want to lose, right, okay? Yeah.
The same thing, but I did it differently. So I did this first,
Mm-hmm.
and then
Right.
this one.
Yeah, that's fine. Okay. Yeah, that would work also. Perfect. Okay. All right. Great. Okay. I'm going to now pass the. Now that we have most people here. I took it up there. I'm going to pass the roll around. Okay. And all right. So here's the way. So y'all got to make sure it gets all the way around. That won't take long. And here's the way this works. It's just a sign roll, right? Okay, you're just going to sign each day. And when I give it to you, sign in the first available slot. Okay, sign in the first available slot. Do not skip slots, all right? Do not skip slots. So sign in the first one that's available. Just use your regular signature, but make sure it's readable. Do not give me your checked signature, for instance, okay, if you've been perfecting an elaborate signature your whole life, anticipating when you're president of the United States or something, right? Just give me a readable signature, okay? And then don't skip slots, and remember your slot. So keep a note of that somewhere or put it in your cell phone somewhere because you got to sign in the same place each time, right? Okay, with the same signature, okay, with the same signature. So yours is going to be easy to remember. You're number 1, right? Okay, but if you end up number 13, you still have to sign there, okay? Don't skip slots. And then remember your slot because you're going to sign there each time, okay? Right, so just pass that around. That's so easy, right? Okay, so the reason I have to make sure you sign with the same signature, I don't want your signature to change through the semester, right, is I do have occasionally, right, people forging other people's signatures, all right? Hard to believe, correct? But that happens, so make sure you sign with your regular signature so I don't get suspicious of that. All right, so remember last time we were talking about sets of data, so we're really shifting gears here away from, kind of algebra and arithmetic things and talking about data, but we're going to put the two back together shortly, okay? So we're going to talk about data for a little while, but I'm going to show you then how to integrate your knowledge of algebra with the study of sets of data, okay? That's a really key goal here in the course is how do we put those two things together, sets of data and algebra, because they seem like, they're both kind of mathematical, right? But they seem like different aspects of mathematics. But we're going to show how we can join the two things together. It's really pretty elementary, actually, right, how we put them together. So we can apply our knowledge of algebra, right, to studying sets of data. Really important skill in the 21st century, right, a skill that can really take you a long place in the workplace, a long way in the workplace, right? So we looked last time at one very simple set of data, right, where we had observed the average yearly temperature at various locations on the globe, right? And we talked about how we could summarize or analyze that set of 15 data values. And, you know, the typical way you would do that, right, is by computing some statistics related to that data, right? Like what's the maximum, you know, that's... I'm sorry, what's the minimum? That's 13.5. What's the maximum? Was 15.5. What's the average of all the values in that data set, right? If you add them all together and divide by 15, that turns out to be 14.6. What's the range of the data values? That means the high minus the low. So that turns out to be 2, right? Okay. Those are all sorts of useful information that we can derive from this set of data. We talked about that last time, okay? All right, now, however, our goal here is not really to look at what's called one variable set of data, all right, where you just have a list of data values. We want to think about what's known as two variable set of data, or data pairs, okay? So the way that data pairs come about in lots of ways, but one way that data pairs can, a set of data pairs can come about is if you're observing some data value and you're observing it over time, okay? Right, you're, say, measuring the same data value each week or each month or each year, right? If you do that repeatedly, you're going to get a set of data pairs, the data value that you're observing, and then also the time at which you observed the data value, okay? And of course, those two numbers are paired with each other, right? You have the time you made the observation of the data value paired with the actual data value itself, okay? And so when you do this, you get a table of, or a list of data pairs, okay? So we looked at sort of our first example of a set of data pairs last time, right here at the end of class, where we looked at this set of data. And in this set of data, so this is a very famous set of data, okay? It's talked about a lot. Here we have measured the average global temperature. So that's the average temperature over the entire year over the entire surface of the Earth, okay? Never mind how that's calculated, all right, okay, because that sounds like a complicated calculation, correct, okay? But nevertheless, what we have done there is measure that average global temperature, and in this table, we've measured it at 10-year intervals, decade intervals, okay? And so we get a set of data pairs from this, right? The calendar year in which we made the observation, correct, of the average global temperature, and then the average global temperature itself, okay? So we have two data values that are paired together there, correct? Okay? Now, the one that's really of interest to us, of course, is the average global temperature, of course, right? Okay? These are just calendar years, right? And so that's easy to measure calendar years, right? But what's interesting here, of course, is this average global temperature. All right, so we want to think about the same problem that we thought about for a list of data values. How can we summarize, or sort of how can we report on what this table of data pairs, right, is telling us, okay? So this is the purpose of our first little class activity today, okay? I want you with the people that are next to you. So this would be in more of a group, right? So these groups of 3 and 4, all right? Here's what I want you to do, okay? I want you to take that same table of data, which is printed on this sheet, and I want you to summarize it for me, okay, on the back of this sheet, okay? You can use words, you can use numbers, okay? You can use graphs. That's why I gave you graph paper here. But I want you to sort of briefly write down what information you can derive, right, from this data table. Imagine that you were going to make a report to the class, right, and you were trying to summarize briefly, right, for the class this data table, correct? Okay, so what things you observed in this in this data table, right? Okay, so numbers, you can write down words, you can write down, you can make pictures, right? Okay, whatever you can think of to explain, quote unquote, right, the meaning of this data table, right? To somehow summarize or report on this table of data, okay? So we're going to take a few minutes to do this now with your group, okay? This will count as a homework grade, though, okay? So I'm going to collect this one. That's why your name is on here. So I'm going to collect this one, and I am going to add it to your homework score, correct? So you get one homework score here, right? So, but there's no really right or wrong answer, right? Okay? I just want to see what you can come up with, okay, for how we could again, report on this table of data other than just tell people, oh, read this set of numbers for me, correct? Because that's not useful, right? Okay, so think about making a report or a poster, but it's got to go on the back of this page, right? Okay, so think about making a poster of this set of data. Okay, so I'll get the instructions there, right? Okay, all right, so get to work on that, okay? And I'm going to come around and observe you doing that. I've got extras, so does everybody bring it back from? That's why I made a few extra there. Oh, okay, yeah, all right. So, yeah, so everyone's got to have one, so you're going to have to sort of copy there simultaneously what y'all are doing, right? Okay, on lots of different sheets, so I can get you a score, okay? So just on the back, right? Write down things. That's nice, right? What other things can you tell me about that, okay? About that set of data there. Words, right? Think about, oh, that's a nice paragraph there. Is there some way you can work some numbers in there? Do you have some numbers in there or some pictures in there, right? Okay, okay, all right. All on the back there, right? Okay. So we only need to take about 15 minutes or something, right? Okay, I think that's enough. Remember now, you can use numbers, right? The same sort of numbers that we were using for that first example, right? Maxima and minima and averages and those sorts of things are all valuable, right? Okay, but we might be able to go a little bit further, right? With a two variable set of data there, okay? You know, debating on what sort of graph to make here. Very good. Okay. All right. So, but come to a conclusion, right? Because we're going to look at in about 15 minutes at what we got, right? Okay. So, pick one. I see y'all drawing a picture there, so that's nice. Okay. That's pretty. Okay, I like that. What other things did you say? Oh, I see. So you wrote these down too. That's nice. Yeah. Okay, that's good.
That's not a whole lot though. Wait, no, we're doing the bar graph on these. That's not a whole lot.
Okay. All right. Yeah. All right. You have to. Yeah. You got to work fast there, right? So make up your mind, right? What you're gonna do. Okay. What are y'all putting down there? That's pretty. Okay. What other things can you elaborate on with respect to that set of data. Okay, so that's a very nice graph. All right, is there something you can tell me about that? Any observations about that, or any other numbers that you can derive from that set of data? Right. Okay, so that's something to put down. Right. Okay. Yeah, describing what you see, right? Okay, and you can also describe that with some extra numerical values, right? Okay, remember those sorts of statistics. You can, yeah, that sort of thing, right? Okay, might help.
Is it one paper per group?
No, everyone's gonna, yeah, each one. So try to copy what everyone is putting there, right? Okay. All right, that looks like that's a good thing to add there, right? Because that's a lot of text to read for when you're making a report, right? Okay. Any rulers? No, I'm afraid I don't. So you can use your, might be able to use your calculator as a straight edge. Is that your picture there, Min? Oh, okay. Oh, yeah, that's right. There's some graph paper there. What other? Oh, I see you wrote some other sorts of things there, right? Okay. All right, that's good. Can you think of some other things to elaborate there?
I wrote the range as well,
Mm-hmm.
which was 1.2.
Mm-hmm. What's happening here? One thing you may ask yourself is looking at the shape of your line graph there. What appears to be happening, for instance, over here on the right? Is that the right hand side? Yeah, over here on the right hand side of your graph. It is increasing, right? Okay. Oh, it's increasing drastically. So there's something there that you might want to comment on, right? Okay.
So
Uh,
write words.
yeah, words, right. Yeah, you can write words too. Yeah. Don't forget you can write words. You can write comments, right? Okay. In your report there. Okay. All right. Keep going there. Okay. So graph quickly here. Selma, okay. Graphing is a really good idea there, all right. But
I should have done that.
that's right. You should have done that. Maybe a little bit different because what happens is it just ends up looking like a horizontal line, right? Okay, we're going to talk about that. Okay, but this is a good illustration of something I'm going to talk about here. All right. So it might help if you had cut down on the range there on the x-axis, right? I mean on the y-axis, right? Okay, maybe between just 10 and 20 or something like
Now
that.
it's when I start
Right.
getting.
Okay. Yeah. Right. Okay. So that one's slightly better, but still has the same issue that she has because you pick so many numbers here, right? Your graph is coming out kind of flat, right? It looks kind of like a horizontal line, right? Okay. So it doesn't really emphasize the changes that are happening there, right? In the temperature, it just looks like it's stable. Yeah. Okay. Right. Same thing. Same thing. You still have a chance to erase, though. Well, you can erase too, right? Okay. So maybe just 10 to 20 or 10 to 15, right, would have been enough on the y-axis. Yeah. So you can tell what's really happening there, right? Okay. Okay, we're going to take about 5 more minutes here, right? Okay, so try to draw fast if that's what you're doing, or try to write down any conclusions that you have kind of quickly there. Okay.
I should have made my graph bigger.
Yeah, when you say graph bigger, I think, oh, well, all right, so you did a couple of funny things there. You put the years here, right? Normally, most people would put the years here, right, okay? And then also, but I think other than that, it would have worked nicely. Okay, you don't need to have a really big range of values on the y-axis because these temperatures are kind of close together. I mean, they're only a few tenths apart, right? So you might want to limit the portion of the y-axis you're looking at to say 13 to 15 or something like that, right? Okay, because if you don't do that, you end up with the graph ends up getting distorted. Okay, I mean it's correct, but it's just distorted. I like the way y'all are working together. Are you gonna get it? You're all gonna get all that on there? Okay. Yeah. So color fast. Remember, you don't have to really make bars, right? You can just put dots. Okay. Yeah. Right. Okay. Yeah. So, all right. Yeah. You don't have to make. If you don't have time, you don't have to make like bars, right? Okay. For the temperatures, you can just put a dot where the temperature is, right? Okay. So that takes less time. Are we almost done there? Okay, so here's what we're going to do with these. We're all going to share, right? And so every group is going to have someone come up for the group on behalf of the group and show your page, right? Your report, okay? You're not really reporting to the class, but we're going to talk about what you have written down there, right? Okay, and then we'll compare, right, what different people did. And then don't forget, you are going to turn these in, right? Okay, for a homework grade at the end of the class. But before we do that, since some people are still drawing, let's take about 5 minutes here, right? So you can go and get a drink or use the restroom, okay? And then we'll come back and do our report out, right? Okay, on what we did, okay? I'm very excited about it because I saw lots of nice things. Yeah. Can you get another one? Sure. Have as many as you want. Okay, are we back? All right. So I want y'all get to vote on your rep. All right, but I just want one person from each of our sets here, right, to just come up and show what you wrote down and what information you gathered from that table, right, and how you summarize that. Okay, so you can show the class. We'll start here. In front, so which of y'all want to do it there for me? Okay, all right, thank you. You are? Leslie. All right, Leslie. Thank you, Leslie, for going first. All right, and show us what you put there. Can I squeeze all of that? This is a bad thing about this. Let's see. I move this back and put that down a little bit. Did that get it there? Oh, okay. All right. So Leslie, what did you say about that table of data? Just comment on what you put there. Yeah.
I did a graph.
You did a graph, right? Okay, and you did a really nice graph there, right? Okay, you did a really pretty graph there.
Well, kind of messed up at the top.
Oh, well, you did it twice. Okay, all right. Well, you don't have to show them that. Yeah, all right. So, okay, all right. And how did you get your points there on the? How did you get your points there on the graph? What are those? Where'd those come from?
From the table.
Yeah, just from the table, right? Okay. So what you were doing there, well, I think what everyone else did, right? Pretty much, right? Is you were taking the rows of the table, right? And you were treating them as coordinates of a point, correct? Yeah, you were treating them as coordinates of a point, and then plotting those points, right, on a set of axes, correct? Okay. Yeah. So, right, that's pretty typical procedure, right? Okay. Think of each one of those pairs of data, each one of the rows of the table as an ordered pair, right? In other words, coordinates for a point on the coordinate system, and then just plot the point, right? And then what did you do with your points?
I connected them.
You connected them with a line, right? Anybody know what that sort of picture is called, what that sort of graph is called? Yeah, that's a line graph. And so if you leave off the lines, though, there, Leslie, that will just be called a scatter plot, okay? So, and actually, what we're going to be doing in the class mostly is making scatter plots. We're typically not going to connect the points with straight line like you often see, okay? We're just going to plot the points itself. There's a reason for that, why we don't want to connect those points with a straight line, okay? There's a reason we want to do that. All right, so Leslie, did you make any other observations there about the scatter plot?
It looks like it's increasing.
Where?
From here and up.
Right. Okay. So on the right-hand side there, right, of the scatter plot, that graph is really going up, right? Your land graph is really going up. At first here, right, it's sort of bouncing around, right? So it goes up and then it comes back down, right? Okay. But over here toward the end of the 20th century, right, and in the first part of the 21st century, it's not just bouncing around. It's just what? It's just increasing, right, okay? So it's really going up there quickly, right, okay? All right, any other comments there? Any other thing you wrote down? Oh, okay, all right. So very nice line graph, Leslie. That's a beautiful line graph. And it would have been a really great scatter plot too, right? I mean, because the scatter plot is part of the line graph. One thing I like that, well, I'll comment on that later. All right, so, all right. Thanks, Leslie. All right, so what about group number 2? All right, so there's our rep. You are? Nadine, okay. So this is great. These are, I think, new faces here. So this is Nadine. Nadine, all right, so what do you have?
I graphed it, but I also found the minimum and the maximum and the average and the range.
Oh, so all right. So Nadine drew her graph differently, though, right?
Yeah,
okay.
I kind of messed up a bit, so I had to.
Oh, I see. So she did it from right to left rather than left to right. Okay. All right. That's okay. All right. That's a little bit non-traditional, right? It's a little bit non-standard, but that conveys exactly the same information there as Leslie's did, right? Okay. For the most part, Nadine, we're going to stick to left to right, okay? Because you're going to confuse me otherwise. All right. But that's really okay. All right. And what else did you do?
So I wrote something. I put
Mm-hmm.
average temperature begins to increase drastically after the year 19.
Right, yeah, that's what we observed in Leslie's. But you also computed some values there, right?
Yeah.
Mm-hmm. What did you calculate there?
The max, the minimum, average, and range.
Yeah, the maximum is 14.7, right? The last year, right? The minimum was 13.5, somewhere there in one of those years. The average is 14, okay? That's an important number, all right? This is a really important number. That average is 14 because most climate scientists will say that our goal is to limit that temperature increase over the next century or so, to limit that temperature increase to above the 13.98, which is approximately 14, right? We want to limit that temperature increase to no more than that's coming in the next century. At least that's what appears to be the case, right? We want to limit that to no more than 2 degrees more than the 14, okay, which is that average, all right, okay? And see, we're not off to a great start because it's already a 14.7, right? Okay, we don't want it to get above 16 in the next century. Actually, now, that may be a little bit optimistic. Now, scientists are recommending no more than 1.5 above the 14, okay? Try to limit the increase, which seems inevitable, to no more than 1.5 above the 14, because above 1.5, the consequences become kind of catastrophic, all right? If the temperature goes up that much. So that's really great. I really like that one, okay? So lots of good information there. And Nadine also wrote down some words, so don't be shy about when you're giving, a report. Don't be shy about writing down words also too, right? Explaining what you see there in your picture. All right, who's our next group? What you already got to show us there? So who is the volunteer, sort of, or the voluntold, as it were, They're pointing fingers. Okay. All right. All right. Someone's got to come. It wasn't that. It's not that scary, right? Okay. All right. I forgot your name. Kevin. Okay. All right. So Kevin's going to show us what they put. And see, there's another really nice. Oh, you wrote down everything beautifully. Why are y'all so shy there? All right. So there's a really nice line graph there. Okay. So you said that was a really huge increase, right, from starting in 1970, right? It's really going up rapidly. Okay. The overall average is 13.98. That agrees with what Nadine put. So I think that's probably the right answer. I didn't calculate that myself, right? Okay. So yeah, lots of the same good information there in that picture. One thing I want to comment on that's really good in your scatter plots and your line graphs is the way you marked off the vertical axis here, the y-axis. You really limited the range of numbers on the y-axis. Here, Kevin, was it Kevin? Yeah, only did this from 13 to 14.7, and that really gives you a very nice picture. If you put, say, 10 to 15 or 10 to 20, if you had marked off those values on the y-axis, you would have gotten the same. It's really the same graph, but it would have looked distorted. It would have looked very flat, like a horizontal line. And you wouldn't have been able to see this important pattern that's emerging here at the end of the 20th century, right, which is those temperatures are really going up very rapidly, okay, at the end of the 20th century. So I really like that, the way you all marked off the y-axis. Of course, it's pretty easy to mark off the x-axis, right? You're just going to mark down the years, correct, that are in the table, okay? All right, great job, all right. Team Kevin there, great job. All right, so what about you guys? Who's volunteering here? Okay, Furman. All right. Furman looks sheepish. So okay, all right. So I'm scared to see what Furman put. All right, okay. So very nice there, right? It's really, of course, right, the same sort of information there, right? Okay. So you calculated these things, and with some nice explanation there, right? Some nice interpretation. Let's see. What did you say? The increase, right, throughout the years, with the most current temperature being the largest. But you didn't say that it was really increasing rapidly after 1970. Oh, you did put that?
No, but I should have added that. I just meant like adding like the recent years as showing that.
Okay, right.
Inevitable.
Yeah. Okay. All right. So, well, no. All right. So, all right. Let's not be that gloomy. All right. But it is going up, right? Here more rapidly at the, on the right. Correct. Now, see what Furman did, right? However, was you put a little bit larger. This is still good, but you put a little bit larger range of values on the y-axis, right, on the vertical axis, and see that kind of flattened the graph a little bit, right, okay? So you don't quite see that dramatic increase here that you see in the other graphs, all right, okay? But this one's still good, all right? I mean, you can still see that increase pretty clearly, right, okay? All right, great, Furman, all right, so these are beautiful reports, okay? What about you guys? Did y'all draw a different type of graph? Some people drew different types of graphs. What did y'all put? Who's volunteering? Arthur's coming again? Okay. Is it Arthur?
Arthur's the neatest.
All right. Arthur is the neatest, okay? All right, Arthur. So impress us with your penmanship here, or your drawing there. All right. Okay. So yeah. So there's another beautiful. Yeah, those are neat dots. Okay, Arthur. All right. So very beautiful dots there.
The
okay.
on the y-axis and the years on the x-axis.
Right. Okay.
And that seemed like the most obvious
That's usually what most people would do, right?
Yeah,
Okay.
at the front, I just kind of wrote an explanation.
Oh, so let's see your explanation there.
The first 4 decades show a pattern of cooling and heating, and afterwards the average begins increasing.
Right.
The increase in the averages could be caused by the world's shift towards industrialization and the world wars at the time. I see that the globe cools after 1940 and 1950 and then continues increasing, possibly due to pollution.
Oh, okay, right. So lots of interpretation, all right, there. That's good. You added a little bit of things, though, that your own sort of knowledge there, right, which is really not in the table, okay? But that's fine, too, okay, if you have that extra information, all right? Great. So there's a beautiful line graph there, right? Okay, and would have been a great scatter plot there, right? Without the lines. Nice. All right. Okay. Great job. All right. Last team here. Who's going to do that for us? Montel. All right. Is it? All right. Are you? Joshua, that's what I thought. Okay. So, Joshua, great. Oh, all right. So, yeah, Josh's got a very nice one because he actually fills in the coordinates, right, for the points there, okay? So he had enough room to do that. So that gives us that really tells us the table too, right, without having to just read the coordinates off of the graph, correct, okay? All right, so you gave us the mid, the max, what's that?
Like much more average.
Oh, that's supposed to be the average?
Yeah.
Oh, okay, all right, so the average there was very close to 14, right? Did you make any other commentary there on the
No, this is like arrows showing like during 1980 through 1960 was like a midterm, like it was randomized, but it was steady.
Oh, I see. I see. I don't see that arrow at the bottom. So you're trying to indicate there, which you could have said in words, all right, that there was a sort of a fluctuation here up and down, right, through about 1970, but then it really begins to increase, right, okay, very consistently there and rapidly right after 1970, okay? All right, so that's something you could have just said that you could have just written out in words, right, okay? So we are going to be writing out explanations for things in the class quite frequently. Even though it's a math class, we're going to write words a lot, all right? So that's something that we have to do from time to time, okay? Wow, excellent. Those were far better than I had hoped, or I was kind of worried about what I was going to see, all right? But those are all really great, okay? So you've got really all the key ideas that I'm going to mention right now. I want to get everybody off of who came up there, off of the list, but I think I've got y'all off already. Okay, so all the ideas there that I'm getting ready to tell you about, I think you've already sort of incorporated those into your graphs, okay? So I'm just sort of repeating here some things that you had already knew or discovered on your own, all right? All right, so in addition, right, to the the typical things, right, that you can that are similar for one variable data, you can do those same things for two variable data, right? So you can calculate maximum and minimums and averages and those sorts of things. But one thing that we're really interested in often with two variable data is how the data is changing, okay? How the data is changing. So in particular, how sort of the important value in the data set, like in this case, the global average temperature, right? How that is changing as the other value in the data set changes. The other value in the data set is, of course, the calendar year, correct? All right. So we're really interested in often, right, for sets of data, the change in one of the data values, okay, as we move from one data value to the next in the table, in the data set, or in this specific example, right, how the global average temperature changes from year to year, right, okay, as the year changes, how does the global average temperature change, okay? And the reason that's important to us was very clear, right, in the scatter plots that you drew, right, or the line graphs that you do, because we noticed that at the end, right, in more recent years, right, the global average temperature was changing, right, much more at a much different in a much different way, right, than at the beginning of the scatter plot, correct? And that change in that global average temperature, that has, as I mentioned, that has important implications, right, for the planet and for you as well, all right, as a person here on the planet, okay? Now, when we study these pattern of changes, okay, if they're regular enough, right, we can use that pattern of changes to make predictions about the future, okay? And of course, for global average temperature, we're keenly interested in making predictions about the future, right, because of the ramifications of increasing global average temperature, okay? Now, so what we're trying to do in our data table is find a way of measuring how the data values are changing in the table, okay? We want to measure that, and there's more than one way, though, of measuring those changes, okay? All right, well, let's just talk about a couple of simple ways of measuring changes in a table of data pairs, okay? All right, so now I'm going to switch to another example, okay? So we may come back to the global warming example eventually, but let's take a look at a different set of data, okay? All right, so, you know, persons with a 4-year college degree, right, which I hope you will have in 4 years or sooner for some of you, okay? People with a 4-year college degree, they typically earn more, right, okay, than people with just a high school diploma, right? So that's why, of course, you're enrolled here, right, in college, okay? And that difference in typical or average salary, that's called the college wage premium, okay? And so that's measured, all right, from year to year, all right? So what I have here is measurements of the college wage premium. This is the average increase in salaries, okay, for people who earn 4-year college degrees versus people who only have high school diplomas, right? And we measured this over several recent years, right, starting in 1993, okay? All right, so what you can notice there is, of course, there are changes, right, in that, there are changes there in that college wage premium, right, okay? But it's still pretty hefty, all right, for each year, okay? So, right, your college education should be a great investment for you, right? Over time, you're going to earn substantially more with a college degree than you could have earned with just your high school diploma. All right. So what we want to do is talk about changes in these in this college wage premium, right, that we observe over this span of time, right, from 93 to 2017. Now, notice this is the college wage premium for men. It's a little bit different for women. Okay. So there's the college wage premium for women, all right? So notice it's slightly less for women, but that is because, on average, women are going to earn less than men, okay? All right, so those are just the facts, all right? So so there's the college wage premium for women over that same time period, okay? All right. So let's talk about how we're going to measure changes that we observe there in that data. All right, so look, the obvious way, the easy way, okay, right, the simple-minded way is to just compute, right, the change in the premium, right, the difference in the premium, the difference in the data value, right, from one observation to the next, all right? So that's just very naive, right, okay? That difference we're just going to call the change, okay, in the data value, all right? And it's very easy to calculate. how else could you calculate it? It's just going to be, I did this backwards, okay? So it's going to be the last data value minus the first, all right? So let me change that formula for you. So notice that can sometimes come out to be negative, right? Okay. If the last data value is bigger than the first data value. Okay, so the change can be a negative. All right. Okay, well, all right, so with that simple formula, right, what was the change in the college wage premium for men from 1993 to 2001? Okay, so that's very easy to calculate, right? Okay, we just have to look at the table and do that subtraction, and that's really easy. Let's see, so the last data value here is going to be the 2001 data value, right? Okay, which is what, 25, right? And the first is what it was in oops, that's for women, right? So for men, it's 40, right? In 42 in 2001, right? Okay, and then in 1993, it was 33. So let me make sure I write this down. So for men, right, 42 in 2001, and then in 1993 it was 33, right? Okay, and of course that difference there is easy, right? Okay, that's just going to be 9. Oh, by the way, now in this table, and this is one thing that's really important to pay attention to when you're reading data values, right? Notice the wage premium, right, is measured in thousands of dollars. Okay, so the wage premium is not just $9, right? Okay, it's $9,000. All right, well, look, that's an easy formula to apply, right? That's really a grade school formula, so nothing complicated about that at all. All right, now, however, here's what sometimes throws students off, okay? I'm going to frequently ask you to not just calculate a change, all right, which is really easy to do, right? You just have to do subtraction, all right? But I'm going to also ask you to interpret that change, all right? So tell me what that number 9 means, okay? In words, write down what that number 9 represents, right? Okay, that's the part that sometimes is difficult for students, and the reason it's difficult is not that you don't understand what that means, but saying it in a way that I want it written down, okay, is what sometimes is tricky, all right? So, anybody just care to suggest what should I say there? What does that 9 mean? Oh, all right, so that's a good thing. Arthur, you caught yourself there. You want to say shift or change, but this is a positive number, right? Okay, so that means that the wage premium has increased, right? Okay, so the increase, so there's a good start, all right? So here's our verbal interpretation of this number. The increase in the college wage premium for men, right? This was for men. Was $9,000, right? And it was $9,000, correct? Okay, so make sure you don't say $9 because that's silly, right? Okay, it was $9,000. That's a good start, okay? That's a good start, but that is not quite correct, all right? So if you wrote down that interpretation, seems very straightforward, right? You're going to lose points. What is missing from that interpretation? So what is misleading about the statement that I just made, okay? Which is sort of correct as far as it goes, but it's still misleading. What have I forgot to add there? Dates, right, okay? So the dates are really important, right, okay? The dates here are really important Because if you say the the increase in the college wage premium for men was $9,000, you're not making it clear, right, to the reader what time period you're talking about. And the college wage premium doesn't always increase by a steady $9,000, right, okay? It increased by different amounts at different times. So you need to make it very clear, oh, I'm talking about from 1993 to 2001, all right? That's really important in interpretation. So if you don't write that down in an interpretation, you'll lose points, okay, because it's not a correct statement. All right, now, where should you put that? Well, it doesn't matter. You can say from 1993 to 2001. I like to say it right up front, though, so I don't forget it, okay? So I would say immediately from 1993 to 2001, the college wage premium for men increased by $9,000, all right? Just get that out of the way, because that's a very easy phrase to forget to say, okay? But it's really important, all right? Well, I'm going to have to put it at the end, okay? So, because I don't have room, but normally I would say that first, all right? So from 1993 to 2001, okay? What was it for women, all right? So what was that change for women during that same time period, right? Okay, so there's the table for women. So what's that change? Let's see, yeah, so and the last value there is 24, right? The first value is 18, correct? Okay, so it's 24 minus 18, right? So that computation, so easy there. You can just do it in your head, right? So the change there is last minus first, so that's 24 minus 18 there is 6, right? So what's our correct interpretation? Right, there you go, right? So from 1993 to 2001, okay, yeah. The college wage premium for women increased by $6,000, right? Okay, so what could be more straightforward, right? One way to measure change there, right, is just to compute the difference in the data values, right, from one data value to another, okay? And also easy to explain, right, what that means, right, because it's so easy to compute, all right? Now, well, see, the easy part, although it's easy, the problem with the change is it doesn't really help us answer usually the questions that we want to answer, okay, about change, all right? So it's very simple, but it doesn't really give us a lot of sophisticated information. All right, so here's my question. Which really increased more from 1993 to 2001? What increased more? Was it the wage premium for women, or was it the wage premium for men? So what would you say there? Yeah, from that same time period, right? From 93 to 2001, which went up more, okay? So there are the two values we calculated, right? Okay. Which one is bigger? What do y'all say? Okay. All right. So Arthur says men's. Why?
Well, the increase was 3,000 more in the college wage.
That's right. Yeah. So someone might say immediately. No, wait. I'm getting ready to say but. All right. Okay. So all right. Okay. Yeah. You just say, 9,000 is more than 6,000. So the increase for men was more. All right. Here's the problem with that answer. Okay, what did the wage premium start with in 1993 for men? Y'all see it there? 33. Okay, and then it went up by 9 to 42. Right? Okay, but for women, it started where? At a much lower value, correct? Okay, it started at a much lower value than the 33. All right. And then went up by 6 to 24. Okay. Now, look. So what we're really looking at here is relatively, right, or proportionately, which one went up more. Okay. See, this one indeed went up by 9. Sounds great, but you were starting at a much larger value of 33, correct? Okay. Here, you went up by 6, not as much, right? But you were starting at a much lower value of just 18. So relatively speaking, or proportionally speaking, really, which went up more? Now someone says women. Why women? Yeah, they did start from a lower value, Furman, okay, but was that low enough to make a difference there, okay? All right. Okay, so here is the issue with computing change just by just by taking this simple difference, all right? It doesn't really allow you to answer questions like accurately, like or clearly, like the question that we just ask, all right? So we have a different way of calculating change, okay? We have a different way of calculating change also, okay, that's called percent change, all right? So with percent change, you're going to calculate the percentage difference in the data values, all right? Not just the absolute or total difference in the data values, all right? And this sometimes gives you a much clearer picture of what's happening with the change in data values. All right, let's see. How do we calculate percent change? All right. Well, that's also pretty easy. There's the calculation, all right? So it involves change, the change calculation, but we're going to turn that into a percentage, okay? Here's the way we turn this into a percentage. So notice you're going to calculate the change here, right? Okay? But then, to turn that into percentage, you're going to divide by the first value and then multiply by 100%, okay? In business, in science, in most fields, when change is computed, it's computed as percent change, all right? You are going to frequently, it's ubiquitous, okay, read, this quantity has changed by a certain percentage, all right? Not this quantity has changed by a certain amount. You will read this quantity has changed by a certain percentage, okay? Almost all change is calculated as percent change, all right, not just total change, okay? All right, so, well, let's calculate percent change here. So this is pretty easy, all right? So let's calculate the percent change for both of them, all right? Let's calculate the percent change for both of them. So what was the percent change for the men, all right? Let's see now. So we take the total change, right, which was what? 9. Divide that by the first value, which was what? 33, correct, and then multiply by what? 100%, correct, okay? So what does that turn out to be? 27 point something, doesn't it? Point what? 27? Okay, so let's write down a couple of decimal places there. Is that rounded correctly? 27? Or is it really supposed to be 28? 27? All right. So remember, this is a percentage now, right? This is a percentage, okay? All right. Now, let's make sure we understand what that's telling us, okay? So what would our interpretation be of that percent change? We would say you're going to interpret it very similar to change, right? Except you will say what? Well, let's start correctly. From, exactly right. So from 1993 to 2001, what happened? No, just say it just like change. So the what? What changed? The premium, right? The college wage premium for men increased, right? Because this is a positive change. It did increase by what? There you go, 27 point, what is that? 27%, right, okay. Did y'all hear that interpretation? Yeah. So, again, start with the time period. From 1993 to 2001, right, the college wage premium for men increased by 27 point, what that is, 27%, all right. That's how you would say that, okay. All right, I'm not going to write that down yet. I may write it down before I post the notes, but that interpretation is important. All right, what was it for women? Okay. That one's kind of easier to calculate, right, just because the numbers are easier. So the percentage change there for women, right, was what? 6 over 18, right, okay, so the change was 6, but the first value was 18, and then times the 100% gives us, what's that, 33.33%, right? Yay, okay, so, which really increased more? Women, right, okay, so the college wage premium for women really did increase more, all right, because it went up by a third, 33.33%, right? So you see, percent change, a different way of computing change, is useful to us. One way it's useful to us is it allows us to compare change in different data sets where the data values might have different sizes, okay? Right, like here, right, the college wage premium for men was typically larger than for women, so the data values were larger for men than for women, okay? But we can still see with the percent change, oh, the women improved more, right, over this time period, right, than the guys did, okay? Nice. All right. So there's another way of measuring change is by percent change. All right, let me have y'all do this one for me, okay? So find and interpret, right? Find and interpret percent change from over that whole time period. So from 1993 to 2017, what was the percent change in the college wage premium for men, okay? So what has happened? Let me scroll up here and I'll show you that table again if I can. There it is, okay? So from 1993 to 2017, that's the most recent year for which we have data. What was the increase or the change? I shouldn't say increase because did it increase? What was the change in the college wage premium for men? So you remember that formula? It's so easy to remember. Last minus first, and then make sure you divide by first, not last, and then multiply by 100%. So you almost always will need a calculator here, okay, when you're calculating percent change. Last minus first, right, divided by first, because we're going to convert this to a percentage. So last minus first over first, and then times 100%. So this is the percent change formula. If you want to write this out not in words, here's the way the book would write down this formula. Using variables, okay? Now, once you actually calculate it, make sure, this is important, write down the interpretation. Write down the interpretation also, okay? So write out a few words there along with the value, because the values without meaning are kind of useless to us. You'll have several problems like this in your homework, so this is good practice for the homework too. But it's the easy thing to do, right? calculating percent change. Okay, so what was that? What did that end up being? Let's see, what's the last one there? Yeah, 40 minus 33, right? That's easy, over 33, right, okay? So be sure you divide by 33 and then multiply by 100%. So we have 7 over 33 times 100%, and there you really need a calculator there to help you write down this estimate. One or two decimal places is usually enough. I think by default we'll use 2 decimal places unless we're told, more or less, right? So what does this turn out to be? 21 point what? 21.21? No, okay. All right. So 21.21%, right? Okay. Now, so our interpretation of that, right? Remember, equally important as the value is, right, from 1993 to 2017, right? Yeah. The college wage premium for men increased, right? It increased. I haven't seen any negative values yet, but things can decrease, right? So not necessarily. It just depends on the situation, and that's why I said just by default, let's use a couple of decimal places. Sometimes we don't need all those decimal places, but just so that we have a consistent rule, let's say a couple of decimal places there. All right. So increased by, right, because this number is positive. So if this number had turned out to be negative, you would say decreased by, but then don't put the negative here again. Once you say decrease, the negative is implied, right? Okay. So increased by 21.21%, right? Perfect. Y'all get that? 21.21? Okay. Now, look, here's the issue with percent change, all right? It has issues too, right, just like change does. And so the problem with percent change is if you just read that value, if you're just reading that, you somehow get the impression that the wage premium has been, consistently increasing, right? From 93 to 2017, but that's not really what happened, was it? Yeah, no. At first it went up, right? And now it's come back down a little bit. So you see, that is a little bit invisible in just the percent change in calculation, right? You don't have this extra information, right? That, it went up and then it went back down. Well, that's just one of the limitations of percent change, right? Okay, so don't think that percent change tells you everything, right? Okay, there are some aspects of the data that, about the change in the data even, that percent change does not tell us, right? In fact, again, right, that this went up and then came back down, right? So first there was an increase and then there was a decrease. That we miss there from that percent change calculation. But nevertheless, despite that limitation, there's another way that we describe or we measure change in a data set. Okay? All right, so, well, this is good. We've gotten our first taste there of analyzing data pairs, right? So we're off to a flying start. Now, one thing we haven't done with this data that you guys did naturally when you were working there is we haven't drawn a scatter plot, so we may want to draw a scatter plot, right? Okay, and talk about scatter plots. Y'all always seem to be really good at drawing scatter plots, okay? But that's an important tool for us too in the class. All right. Okay, so we'll stop there, and I got to have your sheets, right? Make sure your name is on it though, right? Make sure your name is on it. And don't forget you got that homework due Wednesday, but you still have after class Wednesday to work on that, right? Okay.